The last section, 1.5, we're looking at angle relationships, and our vocabulary again is theorems. There's a lot of theorems in geometry. Okay, so when two secant lines or a secant line and a tangent line intersect at a point outside the circle, the measure of the angle formed at the point of the intersection is half the difference between the measures of the intersected arcs. That's a lot. Okay, but for this picture, we have a secant line and we have a tangent line that intersect on the outside of the circle, right here. What it's saying, if I want to look at this angle that's formed, let's say angle JKL. Just trying to figure out what order to go. JKL. I want to find the measure of that angle. That is half of the arc up to the secant line. So that's half the measure of arc K to L. Okay, so if you have the arc length, you cut it in half. If you have the angle, you double it. So, theorem 7, the measure of an angle formed by two intersecting chords is half the sum of the measures of arcs intersected by the angle and its vertical angle. So we have two chords that cross right here. We know these angles are equal, they're vertical. And we know that these two angles are equal, they're vertical. But say we want to know what the angle measure is if we know the arcs. So if I know the arc length of AB and BC, right here I would add those arc lengths and divide it by 2. And that would give me this angle. The angle that goes down to where this intersects. And it goes both ways. If I know these arcs, I would add them, divide it by 2, and then I would get the angle. Okay, last one. The measure of the angle formed by two tangent segments to a circle from the same point is equal to half the difference of the measures of the intersected arcs. Okay, so two tangent segments. That's what these are. I have two lines. And the intercepted arcs are right here. So if I subtract the larger arc, so that'll be this one, minus the smaller arc, times by 1/2, I'm going to get this angle.